Hello everyone and welcome to section A3 of the Algebra 1 part of the Leaving Cert Maths course. And in this section, this fairly short section, we're going to be discussing a thing that you can see now is something known as algebraic identities. So we'll talk about what identities actually are, and then we'll go into two examples involving these things called partial fractions, as well as completing the square, which will come in handy later. So I just wanted to bring attention what the word algebraic identity actually means. So taking us back to sort of junior cert terms, where you likely would have met the difference between an expression and an equation. So an expression is just a group of terms. So 2x plus, that's not an x, let me try again. 2x plus, say, 3y plus z plus w minus 4, and so on, where there's no equal sign in sight or any inequality sign, basically no what we call relation symbol. It is just a group of terms either added, subtracted, multiplied, or divided together, etc. The main difference we're going to be learning is the difference between an equation and an identity. So an equation involves an equal symbol, so 4x plus 3 equals to 8. Well, maybe not that. I'll try and make it somewhat, okay, I'll say 11. This is an equation because it has the double stack equal sign. And we note that this equation is only true for a set number of values. So whether that be a linear equation or a quadratic equation or even a cubic equation, they all have a finite number of solutions, is probably a better way of saying it. So finite solution set. An algebraic identity is a little bit different. So an example of an algebraic identity would be to say x squared minus 1 is identical to x minus 1 times x plus 1 through the difference of two squares. Note that when we're talking about identities, we use a triple stack equals, and this is read as is identical to. So to sum up kind of what an identity is it's a relationship which is true for all what you refer to as reasonable values of our input. So in prefacing what reasonable means, I will get onto just an example in a second, but note that no matter what we plug into this, no matter kind of what value of x, it'll always come out true, because it is just a standard formulation. So what on earth do we mean by reasonable? Well, I will jump ahead a little bit to trigonometry, and I will tell you that sine of an angle theta divided by cosine of an angle theta is identical to tan of theta, provided that cosine of theta is non-zero. So that relationship, that identity is true, provided that we don't have any divide by zero errors. So that's pretty much just a general introduction to identities.